This is Foundations of Math in Pre-Calculus 10, Chapter 3.1. We're going to be looking at the tangent ratio. We know that the Pythagorean theorem is great for solving many right triangle problems if we're given two side lengths. However, we can use similar triangles and use their ratios if we're given one side length and one angle. And we would label the triangle as follows. We have the hypotenuse as usual, and we draw out our angle. The side that's touching this angle is called the adjacent side, and the side that's not touching the angle is called the opposite side. So we said that the angle, if it's the same, it will have the same ratio. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So if the angle is 1 degree, we have 0.017452, 0.999848, 0.017455. And for 2 degrees, we have 0.034899, 0.999391, 0.034921. Okay, we can go on and on and on. However, there's an easier way to do this. We can just use our calculator. So we just have to make sure that we're in the correct mode, because there are different ways of doing trig. There's degree and radians, and sometimes your calculator might be in radians mode if somebody else is using it. We just need to make sure it's in degree mode, and that's with this little symbol here. So I can just do sine 30, and that gives us a half, which is 0.5. Cos 30. And you should check this on your own calculator to make sure you're getting the same values and that it's in the correct mode. 0.866. And tangent 30. 0.577. That's on the Casio. On the Texas Instrument, we go mode, and this one's in degree. So I wanted radians. I would go over here and press enter. And if it was in radians, I just go back over here and press enter. I'm in degree mode. Second quit. And now we can go sine 30 degrees. And that gives us a half. Cos 30 degrees. And I press this button to get the decimal value. It's 0.866. And tangent 30 degrees. And I press this button. Okay, 0.577. That matches our values from the Casio. Now, we use a mnemonic to remember what the ratios mean. So we have so, ka, toa. Okay, so sine theta is opposite over hypotenuse. Ka is cosine theta equals adjacent over hypotenuse. And toa, tangent theta, equals opposite over adjacent. Okay, we'll cover this more later. Today we're just concentrating on tangent, which is opposite over adjacent. So one thing that we need when we're solving problems is the definition. The angle of elevation or depression, or it's also called inclination and declination, is always measured from the horizon. So this is your horizon, this is your horizon. So the angle is measured down for depression and measured up for elevation. And very few problems have the angle measured from the vertical. So with tangent, we have three basic problems to solve. We're either solving for the angle, or the opposite, or the adjacent. We're always given 2 out of the 3, which means we can solve the third one. So, solve for theta if we're given opposite and adjacent. So tan theta, we always write it out in the tan formula. Opposite over adjacent, that's 3 over 5. Theta equals inverse tangent of 3 over 5. And that's approximately 30.96 degrees. So we always do tangent of an angle, and we get the ratio. If we do inverse tangent of a ratio, we get an angle. Okay, never swap these two. You never do tangent of a ratio, and you never do inverse tangent of an angle. It's always tangent of an angle, inverse tangent of a ratio. So let's see this. Shift tan, that gives us inverse tan, 3 divided by 5. And we get 30.96. On the TI, we go second, tan, 3 divided by 5, and we get 30.96. Okay, next problem. Solve the opposite given theta and adjacent. This is theta. It's a Greek letter. And we use Greek letters when we run out of regular alphabets. Okay, so we always write it TOA first. Tangent 30 equals opposite over adjacent, which is 5. So doing the algebra, opposite equals 5 tan 30. So opposite is approximately 5 tan 30, 2.89. Now we don't have to put centimeters or meters here because there's no units here. But if there was units here, you have to put units down here. And finally, solve for the adjacent given theta and opposite. So again, we start off with tan 30 degrees equals opposite over adjacent. So adjacent, we do some cross multiplication here. 3 over tan 30. So 3 divided by tan 30. And that gives us 5.1, 5.20. Okay, if you don't know how to do the algebra, here's the formula you need to know. So theta equals inverse tan of opposite over adjacent. Here we have opposite equals adjacent tan theta. And here, adjacent equals opposite divided by tan theta. Let's look at some problems. Most commercial jets use a 3.5 degree approach slope to land at airports. This will give a smooth landing. And a WestJet 737 is arriving at YVR. It is 4 kilometers from the runway and 400 meters above the runway. Is this going to be a smooth landing? If not, what height should the plane be at for a smooth landing? Let's highlight some important numbers. That one's important. That one's not important. It's just a descriptor. That's important. That's important. And that's about all we need. Approach slope, this means angle of declination or depression. So we'll make a drawing. So this is 3.5 degrees. This is 4 kilometers. This is 400 meters. You can technically draw the triangle this way as well, if you like. So we carry out our calculations. Tan theta equals opposite over adjacent. So tan theta equals opposite, that's the 400 meters over 4 kilometers. These are not common units, so we need to convert. 1 kilometer equals 1,000 meters. The units cancel out, and we have a ratio, and that's what we want for tangent. So this is 400 over 4,000, and this simplifies to 1 over 10. So theta equals inverse tangent of 1 over 10. And this is approximately 5.7. So this is too steep, and it's probably going to be a bumpy landing. Okay, so what height does it need to be at? So tan 3.5 degrees equals opposite. We're looking for the opposite, and this is over 4 kilometers. So h equals 4 times tan 3.5 degrees. So we get that. We calculate it, 4 times tan 3.5, and we get 0.244. Okay, this answer is not wrong. However, we would like to convert it into units that are more meaningful, and that would be meters. So we multiply by 1,000, we get 244 meters. And that actually rounds off to 245, so let's fix that. And we say 245 meters is the proper height. For a smooth landing. Okay, next problem. Bill has an old grain silo. All of the measurement markings have worn out, so there probably were markings there, and they've worn out. But fortunately, he did trigonometry in high school. Put an exclamation mark there. His silo is 30 feet high, and the diameter is 18 feet. He climbs to the top and measures the angle down to the grain on the far side as 20 degrees. How high is the amount of grain in the silo? Okay, so we draw a picture. This is the side view of the silo. So we have 30 feet from here to here. He's measuring 20 degrees. And it's 18 feet in diameter. Okay, so we're calculating this x tan 20 degrees equals x over 18 feet. So x is approximately 18 tan 20. And remember, if you can't do the algebra, the formula is listed here. Opposite equals adjacent times tan theta. Okay, and that's approximately 6.56 feet. However, that's not what we want. The grain is this part. So our grain, let's call it G. G equals 30 feet minus x. That's 30 minus 6.56. 30 minus 6.56. And we actually have 23.4 feet of grain. Let's look at the next problem. Jill was walking along a river. She wants to know how wide the river is. Fortunately, she has a clinometer that measures the angle of elevation. She spots a mature cedar across the river. She knows the average height of the mature cedar is 50 feet. The angle of elevation to the top of the cedar is 40 degrees. How wide is the river? So, highlight important numbers or words. Angle of elevation, and how wide is the river. Okay, so we have a tree, and we have Jill, and she measures 40 degrees, and she knows the height is 50 feet. So you need to be able to draw your diagram accurately. Doesn't have to be a good drawing, but it has to be accurate. And we're looking for x, the width of the river. So we have to make an assumption here. We have to assume eye level is about 5 feet. She's not going to get down on the ground to measure this angle. She's going to be standing when she's taking this measurement. So now this opposite is 50 minus 5. So that's 45 feet. So tangent 40 degrees equals opposite, that's 45, over our adjacent, which is x. So x equals 45 divided by tan 40 degrees, and that's approximately 53.6, but we should round off to 54. It can't be that accurate. River is approximately 54 feet wide. And that completes this lesson.